Hello, dear my students. Today I am here to start our subject structural analysis. In the first lecture, I just introduced the subject of structural analysis. I discussed the syllabus, the references, all this thing. Now here I am going to start the topic, that is, first is what are the different types of structure basically. And then I will discuss a little bit about the analysis part, how to analyze a structure. Now in the strength of material chapter, we studied determinate structure and indeterminate structure. Here also I'll again discuss the determinate structure and the indeterminate structure. In the strength of material, we analyze the beams, those who are determinate. We also analyze the forces along the members of the trusses, and those trusses were determinate structures. In structural analysis, basically, we'll analyze the indeterminate structure. So, basically, the structure is categorized in two ways. One is called the rigid structure and another is called pin jointed structure. Now there are different elements which makes elements that are used in the structure, like beams, like columns, like arches, like cables, like members. These are the elements that is used in structures. Now, how to define the rigid structure? The word rigid means what? The word rigid means the ability to resist the deformation. We already know because we have already studied the equilibrium conditions, the equilibrium problems of rigid body in our engineering mechanics subject, and so also in the strength of material or the solid mechanics subject. We solved different numerical problems of rigid body. So the rigid structure can be defined as the structure in which the beams, columns, and the frames are made and collectively act to resist the moments which are generating due to the applied load. Due to the applied load, the moments will be generated. Now these columns, beams, and frames, their function is to act collectively in order to resist the moment that is producing or generating due to the applied load. So that means these beams, columns, and frames, these will make the structure rigid. Now, what is pin jointed structure? Pin jointed structure may be defined as the structure made of number of straight members joined together at their ends by frictionless hinge joint, or we can say frictionless pin joints, to form a stable arrangement which is capable of carrying the loads applied at some or all of the joints. Now in the solid mechanics, strength of material, or in the engineering mechanics subject, we discussed the pin jointed structure that is called the truss, and that truss, it was the determinate structure. And on that structure, what we basically found, we determined the member forces on the members. The question was like this: find the forces along all the members of the given truss. So we determined the given the forces on the members by using the equilibrium equations. We use the method of section and method of joint also in order to find out the members forces on the members. Now look at this structure. The first one is truss. See, so already you know what is truss. It is a structure consists of number of straight members. Now here the truss, the members are connected. Each members are connected by frictionless hinge joint. Frictionless hinge joint, that is each members, the members, this is BC and this is BE. this member is connected by a frictionless hinge joint. So there will be two forces in case of hinge joint that I'll discuss the support conditions later. So number one is the members are connected by frictionless hinge joint. And the second one, that is the important one, is the load. Load will always act at the joints. Load will never act along the members. If it acts along the members, then it will produce moment about the point, about the joint. So that's why in case of truss, the load will always act at the joints only. And look at this bridge. This one is the cable in order to support the load. So cables are also used in structure, bridge structure. Now another look at these four figures. The first, this one is frames. The columns are there, slabs is there, and this is the beam. Beam is the horizontal one, column is the vertical one. Here again I have shown the column. These are the columns to support the structure, to support the loads, and this is the arches fixed at the ground, and this is the fixed beam, both end are fixed. So this is a rigid structure. This is a rigid structure. This is also a rigid structure. Okay, but this one, the truss, is not a rigid structure. It is a flexible structure. So that's why I have categorized truss by, I have categorized the structure by according to the flexibility or the rigidity. It is one is rigid, another is pin jointed. The pin jointed structure is a flexible structure. Okay, so now I'm coming to the analysis part. What we will do basically, for both the rigid and the pin jointed structure can be analyzed through in two ways. One is the external reactions, that is the support reaction. External reaction for any structure is nothing but the support reactions. And the second one is internal reaction. Then what are the internal reactions? Internal reactions are nothing but the forces on the members. Now these forces may be axial forces, maybe shear forces, maybe these forces produces bending moment, maybe these forces will produce the torsional moment also. Now force, the members, there is a single member. The single member may have these axial force, shear force, and may have the combination of all these. That we will see one by one. So in today's lecture, I am going to discuss about the external reactions, that is the support reactions. Now look at this slide. There are the types of support. The first one is fixed support. Now what will happen in the fixed support? The fixed support is given like this. This is the load I applied at the end. So this is a fixed support. Now what will happen to the fixed support? The fixed support means fixed. There will be no motions along horizontal direction, along vertical direction, and there will be no moment. So that means in three directions there will be three reactions. See, since the horizontal motion will be opposed, so there will be a horizontal reaction, and this is I am taking as Rx. Since the vertical motion will be opposed, so there will be vertical reaction. I am taking it Ry, and this one is the moment. Since the load I have taken it is vertically downward, so it will produce a clockwise movement. So in order to resist that moment, you have to apply anti-clockwise movement, and that movement is along z-axis. That movement is along z-axis. Now, how it is z-axis? Since you are applying load, see, you are applying load. This is x-axis, this is y-axis, this is z-axis. So if we apply a load, along in the normal to the x-axis, so it will produce a moment about the z-axis, z-axis. So I have taken here mz. Okay. So in case of two-dimensional case, if your problem is a 2D problem, then in case of fixed support, you will have the external support reaction 3 Rx, Ry, and mz. And if your problem is a three-dimensional problem, then there will be six support reactions: Rx, Ry, Rz, mx, my, and mz. Okay. So now come to hinge support or pin jointed support. Now what is hinge support or pin jointed support? Hinge support or pin jointed support is a support which permits only rotational motion, which permits rotational motion. So that means the vertical motion and the horizontal motion will be opposed. So that's why there will be two reactions. One is vertical reaction, another is horizontal reaction. So I have taken, in case of 2D problem, only Rx and Ry, and in case of 3D problem, Rx, Ry, and Rz. So if there is a hinge support or pin jointed support is there in your problem, then for 2D problem, the external support reaction will be 2 Rx, Ry. For 3D problem, it will be Rx, Ry, and Rz. Now come to the roller support. Roller support is a support which opposes the vertical motion. Which opposes the vertical motion. That means in the vertical direction there will be a reaction. So I have given a vertical reaction, that is the Ry, and in the 3D problem it is also in Ry. So these are the three main support: fixed support, hinge support, and roller support. These are the symbols, and at the end how it looks like. And this is the external support reaction in case of 2D. That is the external support reaction in case of 3D, that you have to remember it. Now apart from this, there are two supports are also there that we will use. That is the vertical guided roller and the horizontal guided roller. Now see, first one is vertical guided roller. These are the rollers. 1, 2, 3 rollers are there. Now both the rollers have been attached by fixed support. Both ends are fixed. So the roller will move in vertical direction. It will not move in horizontal direction, and it will not also rotate. So that means there will be reaction in horizontal direction, and there will be reactional moment also. So Rx and the moment will be in Z direction. So in case of vertical guided roller, we will have two reaction. One is Rx, another is Mz. The same case will happen in case of horizontal guided roller. Means you just put it in horizontal position, then only horizontal motion will be there, but there will be no vertical motion, there will be no rotation. So in the vertical motion, there will be reaction Ry, and in the moment it will be Mz. So in case of vertical guided roller, we will have two reactions. One is Rx and Mz, another is Mz. And in case of horizontal guided roller, we will have two reactions. One is Ry, another is Mz. So these are the support reactions. Now, in the next lecture, I'll discuss the internal forces on the members. How will you find out the internal forces on the members? Okay, so this is all about today's lecture. Thank you very much.